Good evening, students. Good evening, teachers. Good evening, physicists. Depending on where you're watching this video from, I can also say good morning, good afternoon. But all this while we have been talking about change of position, which we say is motion. We talked about types of motion, but we haven't considered what causes this change of position of the body, which is motion. And today we're going to talk about force. Force, to say, or by definition, is an agent that tends to change the state of rest of a body. As Newton in his first law of motion stated that every object will continue in state of rest unless acted upon by an external force in uniform motion in a straight line. And that is true. This chair I'm sitting down on will remain in this place for as long as no one touches it or no force is exerted upon it to change its position. It will continue to remain at rest. Likewise, there are other bodies that will remain at rest unless acted upon by a force. For example, you need force for you to join two pieces of wood together with a nail. You need force to move a box across the room. That is force. For you to connect two electrical wires together, there is a force that is going to pass through them to produce electricity. That is force. When you throw something up and it falls to the ground, that is force acting upon it. So that brings us to types of force. Types of force, we have contact force and force field. Contact force, example, push, pull, tensions, reactions, and frictional force. Frictional force, for you to be able to move or to stop moving, you need frictional force. When your car is driving on the road, it takes the availability of frictions for the tire to be able to grip the surface of the road, to avoid skidding. And then we have force field. We have gravitational force, which is the force of the earth at which is attract body to its center. We have electrostatics or electrical force, which is a force around charged body. Then we have magnetic force, which has to do with the force around a bar magnet, or a bar magnet. So in all this, there is two difference between these two types of force. The first one, contact force, it needs contact with the body. But the other one is a force field. It doesn't need contact. Example, the force field, the gravitational force, the electrical force, the electrostatics. So they don't need contact with each other. So that's why when I place a magnet and then I place an iron, you don't need to touch the two of them together before you understand that there is a force that is acting around that bar magnet, because the magnet will just literally draw the metal to itself. Same thing happens with electrical field, whereby there is a force that is emanating from these two wires that at the end of the day, when they come in contact, because they say like charge attracts, there's going to be electricity exchange of currents or whatever, but we're not going to that. Then this force tends to change the state of rest of the body. And there is other one thing. I am sitting down here. It takes force for me to sit down here, and it will take force for me to stand up. But mind you, me sitting down here, I don't need an external force for me to leave this place. All the force I need is within me. So which means Newton's first law of motion does not apply to me when it comes to me leaving this place. The same thing with a combustion engine that is powering a car. You don't need an external force to help the car to move unless the car breaks down. But there is another bigger topic. See you in our next video.